Hi friends, welcome back. Today we are going to solve AtCoder beginner context 117 problem Streamline. Before we start looking into the problem details, some examples related to this problem and the Java solution for this problem, I want to mention that my channel is dedicated to help people in their Java and coding interviews. You will find lots of helpful videos on my channel that can help you in your Java and coding interview preparation. On my channel there are over 300 solved different varieties of coding problems which are asked by big tech companies like Google, Facebook, Amazon, Apple, Microsoft, Yahoo and many other big financial companies, and those are selective problems to cover wide range of varieties that are very important for the coding interview preparation. So if you are preparing for Java interviews or coding interviews, this channel can definitely help you in your interview preparation. So please subscribe to this channel now. So first we will go through this streamline problem statement. We'll understand the problem with examples and then we will formulate our Java solution. So let's start. So we will play a one player game using number line and n pieces. First we place each of these pieces at some integer coordinate. Here multiple pieces can be placed at same coordinate. So our objective is to visit all the m coordinates x1 to xm with these pieces by repeating the following move. So they have given us a move, like what move we can do, and we have to visit all the m coordinates, right? So choose a piece and let x be the coordinate. Put that piece at coordinates x plus 1 or x minus 1. So we can move the piece to x plus 1, means we can move it 1 unit forward or 1 unit backward, right, using one move. So note that coordinates where we initially place the pieces are already regarded as visited. So once we put a piece in the initially we are given a choice to put the piece at whatever coordinate we like, right? So that is not counted as a move basically, right? So that's what they are saying. So find minimum number of moves required to achieve the objective. So they have given us constraints. So n is between 1 to 10 raised to 5 inclusive. M is also between 1 to 10 raised to 5 inclusive. And xi means the units, like where the coordinate is between minus 10 raised to 5 to plus 10 raised to 5 inclusive, right? So let's take a look at one example here. This first example we will take on the whiteboard where it's easy for explanation, right? I can easily explain it here. So this is the input that's given to us. So number of pieces we have is 2, right? And these are the 5 coordinates that they have given us. So let's just draw one line, right? A coordinate line, something like similar to x-axis, right? So this is our coordinate line. So let's consider that this is 0, right? So let me use this blue color. So 1 2, let's just put like here the coordinates where that we want to visit all these coordinates that we are writing, right? 1 2, this given 10 12 and 14. So let's just assume that this is 10, this is 12 and this is 14. So we want to visit all these coordinates, and in the problem description they have explained us what move we can make, right? The move we can make is, for example, let's say, for example, let's just assume that if we put one piece here, then we can go 1 unit backward or 1 unit forward, right? So either we can go to 1 or we can go to 3 using a move, right? So that is the move that we are allowed to make. And in the beginning they have given us two pieces that we can place anywhere where we want to place the pieces on this coordinate line, right? So and our goal is to visit all these coordinate points, right? Like 1 2 10 12 14. So all these points we want to visit. So let's just first visually like solve this problem using this coordinate line, and first you will understand it better, then we will go through the approach of how we can algorithmically solve this problem using Java, right? So two pieces we have, we can put these two pieces, let's say we are putting one piece at 1 and other piece at 10, right? So we want to now visit all the other points, correct? So using the moves, right? So we can make one move from 1 to 2 and we can visit 2, right? So this is one move, right? So now we already visited 1 and 2. When we put a when we put a piece at 1, it is counted as it is visited, right? So it's already visited. So 1 and 2 is visited. 10 is also visited. So now we will use the moves to visit 12 and 14. So how we can use it? So tell 10 to 11 we can do. So let's just assume that this is 11. So this is one move. From 11 to 12 we can move. This is second move, right? From 12 to 13 we can make one move. So this is 13, right? And then from 13 to 14 we can make one more move. So this is 3 and this is 4. So these are total 4 moves needed so that we can visit all 10, 12 and 14, right? So this 4 plus this 1, so total moves we will need is 5, right? So that's why the answer is 5 here, right? So this is what the problem is. So let's take another example also here. So this is another example that I created for your better understanding. So here number of pieces are 3. This is given us, right? And number of coordinate we want to visit is 6. So I already marked the 6 coordinates that we want to visit, like 1 to 4, right? 1 to 4 and 12, 14, 15, 12, 14, 15, right? So if we put our pieces like this, right? One piece we can put it at 1, then next is 4 and next is 12, right? So let's just count the number of moves required to visit all the coordinates. So from 1 to 2 we can go and we can make one move, we can visit 2 here, right? So 1, 2 and 4 is already visited now, right? After this move, now let's visit let's start making a move from 12 to 13. We'll make one move, right? And 13 to 14 will make another move, right? So this is one more move. So this is two moves done. So 14 is now visited. From 14 we can make one more move to visit 15, right? So total these are 3 moves, right? So 3 plus 1, total 3 plus 1 is 4 moves will be required basically, right? um, so that we can visit all these coordinates. So let's just now figure out like how we can solve this algorithmically, right? So what we will do to solve this using an algorithm. So let me just move this little bit so I can make some space here, or I can just clear this line, I think. um, So first thing is this is the array of the coordinates, right? We will sort this array. So let's say after sorting it will look like this, right? 1, 2, 10, 12 and 14, right? So this is after sorting. And then what we will do is we will take the difference between these two and we will put this into priority queue, right? So we will use a priority queue, which is the min max heap implementation is Java, right? So this is, let's say this difference is 1, correct? Then this difference between 2 and 10 is 8. Then this difference between 10 and 12 is 2, and this difference between 12 and 14 is 2. So we will put all these values into a priority queue, correct? So let's just assume that this is our priority queue. So I'll put like 1, 2, 2, 8, right? 1, 2, 2 and 8, right? So this will be our priority queue values. So we will start getting these values from priority queue, and we will only consider these values, right? These three values we have to consider basically, and once we consider these 1 to 2 values, then it will give us the answer, which is the 5, right? So this is the answer. And why we are not considering it? Because when we are putting the like any piece at one coordinate, that is not considered as a move, right? So that's why we will not consider it. So let's take a look at the Java code so it will be more clear to you. So this is the streamline problem. This is the input that's given to us. This is the first example we are taking, right? From this is the example we are taking. So after that, first thing is we will sort the given array, right? This array we will sort. So after sorting, it will become 1, 2, 10, 12, 14, right? And after that, we will define a priority queue here of integers. We will add, so see, like we are starting at 1 and we are adding I minus array of I minus 1, right? Array of I minus array of I minus 1. So these values we are adding into priority queue 1, 2, 2, 8, right? We have got these things as a difference, right? These things are difference between 1 and 2. This 8 is difference between 10 and 12, right? Then 2 is difference between 12 and 10. So these values, right? Then 12 and 14, the difference is 2. So this difference we are going to add into priority queue here into this for loop. After that, we just created one answer variable that we are going to output at the end, and we have one variable end which is the we'll get the maximum between m minus n. So m minus n is 5 minus 2, right, which is 3, and 3 and 0 maximum is 3, right? So 3 is the maximum. So we'll go from 0 to I is less than 3, means 0, 1, 2 basically, right? And what we will do is we will just poll those values from the queue. So as you can see here, so we'll just have in the for loop we are going 0 comma 1 comma 2, so only 3 values we will get, right? So this first value, then second value, and third value we will get basically from priority queue, right? And then we will just sum them up and we will form our answer, right? And we'll just print the answer here, correct? So this is the way we are going to use the approach of priority queue to solve this problem. So first we will sort the array, then we will actually get the difference between the two adjacent values, right? 1, 2, then 10, 2, like then 12, 10, then 14, 12. So all this adjacent value difference we will get and put it into priority queue, right? Because why this logic works, because as you can see here in the this coordinate system, right? So minimum move we will have to just take the difference between this 2 and 1, right? 2 and 1 we will take the difference. Also here between 12 and 10 the difference is, see, this 12 and 10, right? So difference is 2. So 2 plus 1 is 3, and between 14 and 12, right, the difference is 2, right? Because you can say this is like a sorted array, right? 1, 2, 10, 12, 14, right? So if you want to, if we want to visit all the coordinates, then as you can see we are taking difference between the neighboring elements, right? So first difference is 1, second difference between 12 and 10 is 2, and third difference is between 14 and 12 is 2, right? So these values we have to add basically, correct? And this will tell us basically minimum number of moves that are required, right? And we are not actually going to add this difference, right, between 10 and 2, correct? 10 and 2 difference we will not be adding, right? Because uh, that will not minimize the difference, right? That will not minimize the difference. That's why it is at the end in the priority queue, right? And we are not considering that value. As you can see, we are only calculating the end, which is maximum of m minus n, right? So only those many values we will take, like 5 minus 2 values we will take, which is 3 values we will take from priority queue. These 3 values, right? 1, 2, 2. This 8 we will just be ignored basically, right? So this is the way we can implement the Java logic. So let's run this problem snippet. So we are getting 5, which is the correct answer. So let's take a look here. So 5 is the correct answer here. So there are other examples also. We can just take this. This is another example. Let's just make sure that this also works. So I'll just modify this quickly. So 3, 7 is given to us, and these are the coordinates that are given to us that we want to visit, right? So let me just quickly modify this input. So let's give it a run now. So as you can see, 19 is the answer, which is the correct answer here, right? So we are getting correct answer for our Java solution. So this is the logic how we can solve the streamline problem at AtCoder. So first, how we have, let's just do a quick recap of how we solved the problem. We just first sorted the array. After that, we took the difference between two adjacent elements in the sorted array, and we put those differences in the priority queue, and then we just calculated this m minus n, right? M is 5 minus n is equal to 2, right? Which is equal to 3, right? So we will take these three uh, numbers from priority queue, like 1 to 2, and then we will just add them up. So once we add them up, it will tell us the number of minimum moves that are required, right? So as you can see, we have to find out minimum number of moves required to visit all the coordinates. So this is the logic to solve streamline problem. If you are new to my channel, you will find a playlist called as AtCoder that has couple of AtCoder solved problems explained with a whiteboarding session and examples. Apart from that, there are three other important coding playlists. One of them is called as Leetcode and Leetcode solutions. Others are called as Code Forces and Code Chef. So all this playlist has over and all more than 300 different varieties of coding problems solved and explained using whiteboarding sessions and examples and Java code for your easier understanding. And though those examples constitute very important coding questions varieties such as DFS, BFS, matrix problems, graph problems, binary search tree problems, problems related to priority queue optimization, linked list strings, and many other logical questions that can be solved using different data structures of Java such as set, map, queues, stacks. So you will get vast varieties of good practice for your coding interviews. If you like this video, if you find this video helpful, and if you like the way this video has been created using whiteboarding session examples and Java code, and if this video helped you in better understanding the problem and the solution, then please give it a like. Also subscribe to the channel. Your subscription to the channel is really important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. One of the main goal of the channel is to help people in their coding interview and Java interview preparation by demonstrating important coding questions, by solving them using whiteboarding sessions, examples, and Java code, so they can understand how to approach different varieties of problems using Java data structures, and how to use data structures, APIs, and libraries of Java to solve different varieties of coding problems. So if you like this video, if you find it helpful, then please give it a like. Also share this video with your friends and colleagues who might get benefited by watching these videos in their interview preparation. I'm gonna put and share the Java solution that we just discussed and saw here on my GitHub account, and I'm giving you the link of my GitHub account where you can check it out, the solutions, and practice the solution with different examples. And thanks for watching this video.